right, so it looks like we've still got some folks joining. So I'll do some introductions here. Again, welcome if you're just now joining to the Interstate Batteries ProClinic webinar. My name is JD Feltz. I'm a product marketing manager at Interstate Batteries. I'm joined by my friends Jeff Barron and Gale Kimbrough. Welcome, Jeff. Hi, Gale.
Hey.
I believe Gale might be having some.
Hello.
Hey, there he is. Okay. We're having some technical difficulties on Gale's side, so it may, Jeff, just be a one-man show today. But thank you both for joining us. For the next hour or so, we're going to be taking a look at the marine and RV category. We'll walk through some of the industry insights. We'll talk about battery types, chemistries, ratings. We'll dive into some of the new technology, enhanced flooded batteries specifically, how to recommend and talk with your customers about the right battery for their particular application, how to calculate amp hours and load, and then best practices around charging and maintaining. Like I said earlier, if you would open up that Q&A tool and ask questions throughout this webinar, we'll answer what we can live, and anything we don't get to during the meeting, we'll save some time at the end, about 15 to 20 minutes, to go through those questions as well. So with that, let me more properly introduce Jeff and Gale. These gentlemen helped us build this, the content that you're going to see today. These gentlemen have close to 100 years of combined automotive and battery experience, anything from turning wrenches in shops to owning shops and part stores, as well as developing Interstate Batteries' state-of-the-art ISO IEC 17025 accredited testing lab. That's a mouthful. In this lab, we test all of our product lines to ensure that we are carrying and taking out to the market the highest quality product we can. So Jeff and Gale, thanks again for joining us.
Thank you for having us.
Alrighty, so during this webinar, you're going to see some content that is meant, maybe more geared towards technicians, some for shop owners or service managers. So we'd like to do a quick poll just to understand what that audience mix looks like. So if you would, Lindsay, kind of cue up that poll. Please go in and select what role or job title best describes you. We'll give you just about 30 seconds to do that. Lindsay, as you see some of the answers come in, if you want to queue up the results, that'd be great. Thank you. All right, so we still got some people answering here. So far, it looks like we've got owners and managers making up the majority, but we've got a good mix of technicians, service reps, instructors. Awesome. All right, so to start off, if we want to back up one slide, there we go. Want to walk through some of the high-level industry insights. There's a lot that transpired in 2020, so we'll walk through that, and then we'll jump into some of the battery-specific portion of this. So starting on the marine side of the industry, we saw a massive acceleration in new boat purchases in 2020 due to the pandemic. The National Marine Manufacturers Association reports 310,000 new boats sold in 2020. About 50% of that is made up by small fishing boats and pontoon boats. If you look at the map, you can see that the East Coast really drove most of that growth in 2020, with Florida leading the way. All in all, we're seeing outdoor recreational activity up across the board, again, largely due to the pandemic. And the RV side is no exception. When we look at kind of the reflecting back on 2020, late April, early May is when people realized this pandemic wasn't going away, and they took off for the outdoors, and RVs were a target. It was a way to socially distance, to maintain travel plans in a safe manner for those folks that are reluctant to maybe hop on a plane or book a hotel. They still remain the ultimate choice for social distancing. They're also being used. We've seen a trend of RVs being used as home offices. So they can work remotely, but they can also park an RV in their driveway and have a place to go to if they don't have the space within their home. This industry has seen a massive wave of positive public press over the last 10 months or so. Newspapers, magazines, social media, everybody's talking about it in a very positive way, which is really magnifying the growth that we've seen. Of the new RVs sold last year, about 55% are estimated to make up those first-time buyers, which is a huge jump. It's about a 30% lift in first-time buyers, which is awesome for this industry. You've got a lot of new people jumping into this category, and it's exciting. Overall, millennials have been driving the largest amount of growth over the last several years. Predating the pandemic, we've seen millennials largely forego, in a lot of cases, maybe a 30-year mortgage, not saving RVing for retirement, but rather doing it now in their prime. And so we've seen that millennials are social people. They're on these social media platforms sharing their experiences and inviting their peers to jump in. So we've just seen a massive growth in millennials jumping into the RV side of the industry. Another trend that we've been monitoring is this increase in electrification. We've seen a steady rise both on the boats and RVs. If you look at some of the new models of boats coming off the line, they're coming equipped with more niceties, screens, multiple fish finders, better sound systems, hand warmers, seat warmers, things like that. And we expect that to continue to drive the adoption of new battery technologies. Think AGM, enhanced flooded batteries, which we'll talk about here in a little bit, as well as lithium. While it's very expensive, we've seen lithium emerge on the marine and RV side as well. A couple of insights I wanted to share here from our 2020 consumer study. Interstate conducted this last year with about 650 boat owners. I don't have time to unpack that study, but there were a couple of insights that I felt were valuable and worth sharing with this particular audience. So the first one here has to do with motivation. So we asked, when it comes time to replace your marine battery, what do you care about? What's top of mind, and what are you willing to pay more for? This is by no means an exhaustive list. We just kind of condensed it down to the top few. And what we heard is that largely consumers, boat owners, are looking for a product that they believe is going to be longer lasting, has high quality, and is backed by a trusted brand, and the great value coming in forth. So for the most part, people are looking for product that they believe is going to be reliable. They want their equipment to work when they need it to work, and don't want to, they're not just out looking for the cheapest product. They want that reassurance. Another interesting note here, when we asked, what was the, thinking back to your last marine battery purchase, what was the trigger point? What caused you to have to go shopping for a new battery? Was it an emergency out on the water? Was it a semi-emergency, which would be a failure identified at the marina or at home? Or was it replaced preemptively through regular maintenance? Surprisingly, 55% reported replacing their battery through regular maintenance. This is quite shocking, because if you look at some of the other segments, it's the opposite, right? Take automotive. When we ask the same questions of automotive consumers, it's about 73% replaced through an emergency, right? You don't think about your automotive battery until something happens. Not the case for marine. It's more top of mind for most of these boat owners. They want to ensure that their equipment's going to work when they need it to. And so a lot of times, at least here, a little over half will replace before it's actually failed. All right, so now that we've kind of walked through some of those high-level industry insights, let's get into the battery specifics. So Jeff, walk us through, starting with starting batteries, walk us through the different types of batteries and the purpose they serve.
Awesome. Thanks, JD, and welcome everyone. Yeah, so you got to look at the different product lines that we actually have out there. So when you're looking at starting batteries, you're looking for a high burst of power to crank up the engine and get it spinning over, so that way everything can take control and alternators take over once it gets running. And then you also look at the power that it's supplied, by the alternator and or the generator, whichever you want to call it. So once you get this thing cranked up, the battery's done its job. I mean, that big job was to spin this engine over and get everything running. And so once that's taken care of, that job is done for the battery. So it's just now there as a stabilizer. If you try deep discharging these things, and a lot of people will do this whenever they pull up and go to wash their car, they'll turn the switch in the accessory mode on and let the radio blare and all that. Well, when you start deep cycling a starting battery like that, they don't really like that. So what is happening, you've got a bunch of really thin plates in there that are designed to output high amperage for a short duration. So when you try deep cycling that with lower amperage and drawing it down really low, you're kind of buckling the plate, so you can definitely shorten the life on them. We want to look at some of the different ratings that are out there. Marine cranking amps is one that you guys are very familiar with, and we can actually do that test here in the lab, which we often do. We also do co-cranking amps. So marine cranking amps is the same thing as cranking amps, and it's done at 32 degrees Fahrenheit or 0 degrees Celsius. And it's the amount of amperage that this battery can sustain for 30 seconds without the pulse voltage getting down below 7.2 volts. Now, yes, that is a very stringent test, but keep in mind it's at 32 degrees. So cold cranking amps is a little different. We do that at 0 degrees. We have a walk-in freezer here that we can actually get down. We can actually go down to -40 if we wanted. Not that we want to do that. We want to keep the battery at 0 degrees, true cold cranking amp test, or -17.8 degrees Celsius. And we're going to hit that battery with whatever the rating is on that label for 30 seconds, and it has to sustain that for 30 seconds and not drop below 7.2 volts. That is a very stringent test on a battery. Let me just tell you that. 32 degrees is definitely a hit, but CCA is definitely the worst. So let's look at the cycling battery aspect as well. So when we talk about cycling, it's a little bit different story. So cycling is one discharge and one recharge is considered one cycle. So your vehicle, when you start it up in the morning and you drive to work, that's one cycle that it's actually incurred. So you can typically see automotive cranking batteries go anywhere from 8 to 10,000 cycles within the life of them. Now, when you look at different batteries like the marine side, when you're looking at deep cycle product, now these like a lower amperage for a lot longer drawn out time. They provide power to any of your accessory loads like your fish finders, your GPS, your stereo systems. So these are designed to take care of those lower amperage loads for long drawn out durations of time versus what a starting battery typically does. So your marine applications, off grid or quiet hours as they call it, everybody's got to use the battery. So that's what we look for. And a lot of these have got what we call a reserve capacity rating or an RC rating. Now, this is another standard SAE test that we perform here in the lab. It's done at a 25 amp discharge at 80 degrees. Now, what we're going to do is we're going to hit that battery with 25 amps, and it's going to be fully charged when we start. And we start calculating the minutes from the time we hit it with 25 amps until that voltage gets down to 10.5 volts. Now, once we get it down there, we're going to calculate the minutes, and whatever that rating is on that battery, we're hoping to meet it or exceed it. Now, your 6-volt batteries, most of those you're going to be putting in series to get 12 volts. Those are typically done at a 75 amp discharge. So you'll have ratings on there as well, like 445 minutes at 75 amps or 445 minutes at 25 amps. So look at your different ratings that are on there. We also have dual purpose batteries. Now, dual purpose batteries are kind of the lower end of the spectrum because they can actually do cranking and they can also do cycling. They don't do both very well. So that's where that common denominator comes in between whether you're looking for a dual purpose because you don't have that many auxiliary loads that you're going to use it, or where you've got a whole bunch and you really need a true deep cycle battery. So that's where we look at all these different product lines that we have. We look at the chemistries from there as well. So you've got the flooded lead acid battery. It's conventional, less expensive, maintainable. Now, maintenance really comes into play because I know a lot of you guys have heard maintenance free. Well, we've always said if the caps will come off, that's maintenance available. They are also the slowest on recharge as well. So keep that in mind when you're out there looking and trying to sell product or looking for product for yourself. We also have the AGM battery, which is an absorbed glass mat. Now, these do have a little bit longer life. They're vibration resistant. They do accept a charge faster than your typical flooded product. They are excellent for starting and or cycling. And we've got a couple of lines that are actually a 2-in-1. They're non-spillable. They are a little bit more expensive than what your flooded product is. But now, if you really want to go to the extreme on pricing, that's where you go to the lithium. So lithium is a newer technology. It's got a lot of benefits where you can actually go down to 100% every time you discharge that product, and it will come back and recharge faster than your flooded or AGM product. and you can get anywhere from 3,000 to 5,000 cycles out of them. So that's another great advantage. They're 40% lighter, so as the older we get, the less weight we like to pick up. So that comes into play as we're moving down the road. The rapid recharge, these can go anywhere from 3 to 8 hours. You can have it back up to 100% depending on your capacity. And they are the most expensive battery you're going to find out there for deep cycle.
So Jeff, the important thing here, I guess, the takeaway from that is going to be, as these folks are engaging with customers, just understanding that there are different types of chemistries that serve different needs. And so, understanding that and understanding how the customer is going to use those in the application is going to be important.
Oh yeah, definitely. And then, we throw in another chemistry in here as well, JD. We throw in the enhanced flooded product, or EFB. Now, a lot of people believe that this is kind of new to the market. Well, no, it's not. It's been around for many years, and it actually got started over in Europe in the start-stop technology vehicles. So we were looking at that, and as the industry started developing here in the U.S., getting wide span on adding more electronics, we started looking into the EFB start and stop technology, and also looking at the makeup of the grids and the plates. And we thought, heck, these could actually be used in a deep cycle application and still be able to work all the different electrical loads and recharge efficiently. So it's been introduced in the marine and RV application now. And of course, Interstate, we are offering this now in our product line. So it's a new product for Interstate as far as offering to the marine or RV applications, but it has been around for a long time, believe it or not. JD, looks like we're going to throw up a poll question.
Yeah, Lindsay. So let's queue up the next poll here. Thanks, Jeff, for that. Would like to know, does your company buy or sell Interstate batteries today? If you wouldn't mind just going in, give you a quick minute, just a quick yes or no. And then Lindsay, when I'm not able to see, but if you're able to see kind of what % of people have answered and you feel like we've caught most of that, we can go ahead and close out the poll and move on. We'll give people a few more seconds. All right. Good deal. Let's move on to the next slide here. There we go. So Jeff, walk us through kind of the breakdown here of the different types of chemistries here, some of the purposes they serve. Walk us through this.
You betcha. So on your traditional lead acid batteries, the ones that we always say your maintenance.
Jeff, you're a little bit quiet. Sorry, you might getting closer to the mic.
Oh yeah. Hey, is that better?
Try that again.
How about now?
No, you're worse.
Wow.
No.
How about now?
You still sound distant.
Oh, no way. This is not good.
So I'll walk us through this as you kind of figure that out, Jeff. I'll take us through it. So starting on the left side here, we have traditional lead acid batteries. These are the products that Jeff just spoke about. It's what you typically think of. You've got some that will start. You've got some that will cycle. They are not maintenance free generally. There are some out there, but the majority, kind of the old school, either recessed bit caps or the raised bit caps that you pop off and you can maintain and check water levels, things of that nature. Most are not non-spillable, so you still have that risk. You can't mount in any direction. In terms of life or longevity, how many seasons you're going to get out of a battery, these would give you the lowest out of the batteries that we're looking at here, and then just providing kind of a general, retail price range dependent on manufacturer and group size and things like that. Moving on, kind of to the right there, enhanced flooded batteries. Same thing. They start, they cycle. Really strong cycling characteristics. They are maintenance free. These are sealed. You can't access. They are non-spillable. And then you can see there the main benefit of an EFB is you're getting twice the life that you would out of a typical lead acid battery. And then to the right there, we have AGM, absorbed glass mat. Again, starting cycling capabilities. They are maintenance free, sealed, and non-spillable. And again, another step up in terms of life, throughout the life of the battery. And then you're again having a bump up in terms of retail price. You're looking somewhere in the neighborhood of 210 all the way up to 400 when you get into some of the the premium pure lead AGM products. And then lastly, as Jeff mentioned, lithium. Today, these are really designed only for cycling. They don't like cold weather. So when you get into cold cranking amps and things like that, they're really not designed to do that. But they are very good cycling batteries. Again, maintenance free, non-spillable. And then in terms of life, we've seen data suggesting these things can be cycled over and over and over again. But they also come with a very high upfront cost.
Hey, JD, can you hear me now?
You sound great now, Jeff.
Man,
Yes.
well, it's like the cable. I don't know what happened, but she's all working now. Thank
All
goodness.
right. Yeah, you're crystal clear.
Sorry about that, guys.
You're fine. So yeah, Jeff, walk us through, just kind of unpack the Interstate Marine EFB for us a little bit. How's it different, and what are the benefits?
Man, there is a huge difference in the way that these actually operate, and they are a true maintenance free, as we call it. You cannot get into this thing unless you really destroy it, and that's not going to happen. So they are a very high cycle pace formula that's actually built within these things. It's also got a reinforced positive strap that actually goes across to connect all the plates. And it's got a glass separator that's actually kind of embedded into the paste material. So it's almost like you've got your concrete, but you got your rebar and everything that actually hold it all together. That's kind of what we look at when we've got this plate all taken out and disassembled. It also has a graphite additive on the negative plate that actually helps out when it's performing in a partial state of charge from day one. So these batteries are really good. Now, a lot of folks are kind of confused about when we talk about cycling, and we're going to talk about that. So our key benefits here is it's actually performing just like an AGM without the price. You've got twice the cycle life that you would have with a traditional flooded product, and we offer that 2-year warranty based off of just what we've seen in the field. And we've got that basically the middle of the road now. So we've got our lower end with the 1-year warranty. Now we've got a 2-year warranty, and we've got some of the others that exceed 3 to 4 years. So there's a lot of different technology that's actually went into this thing. And I won't go through all the bullet points on this thing though, JD, but we talked about, beating this thing up, the battery itself. And let me tell you what, we put this thing through the biggest test you could ever see on product. And, we started out with a test plan of 40 batteries, and we broke them down into different segments of the different testing zones that we wanted to run through. So this is just kind of a finite list here of what we went through on testing it, just to see what it would actually do. Now, we put this through automotive applications, marine applications, commercial applications. We put it through everything just to see how it would do and if it would perform. And let me tell you what, this thing done really well. High temperature testing was the number one thing that we look for corrosion. And these things went through these live tests without adding any water. Now, of course, there is a little water loss, but nothing what you would actually see on a typical flooded product where you end up adding water, every 8 or 9 months anyway.
All right. And for those folks on the call as well, we'll be sending out some more detail around the Interstate Marine EFB. We've got a dealer promo that we're rolling out. So keep your eyes peeled for more information coming out in the next week or so.
Perfect.
All right, Jeff, take us through, kind of help us educating our consumers on ratings, what they mean, how to calculate. Walk us through that.
You got it. So one of the main things that you see on your battery is an ampere hour rating. And that is if it's a true deep cycle, it'll have an ampere hour rating, and it's typically done at the 20-hour rate. So what that means is it's the amount of amps times the amount of hours that you're going to be running before that voltage drops down below 10.5 volts on a 12-volt battery. So we look at all these different creature features, as we call them, that we want to be able to run with the engine either off or without having shore power hooked up. So ampere hours really come into play, and especially if you know exactly how many amps you're going to be pulling and for the length of time that you're actually going to be pulling on them, this will kind of help you out. And on our next slide, we're going to kind of walk through some of these different ways to figure that out if you don't have a ampere hour rating on there. So reserve capacity is another, and it kind of references back to ampere hours if you want to figure it out. So when you have no ampere hour rating on there, you just take the reserve capacity and you do it times 0.6, and that's going to give you an estimation. It's not an exact, but it's going to give you an estimate on what your total ampere hour is with that battery itself. Now, we kind of got a little estimation down here for the battery needs, and we're talking about lights and fish finders and trolling motors. And so what we've done here, we've kind of calculated up the amp draw and the hours, and then we combine all of those totals together to get our minimum requirement for ampere hours. Now, our examples down here, we're showing 180 reserve capacity rating. So if we do that by times 0.6, we come up with 108. So our total minimum that we needed there was at least 80 ampere hours. So that 108 does give us a little bit of a buffer there. So we've got not, double, but we got a little bit more capacity than what we need. Now, if we've got a battery that's rated at 150 on the reserve, and we do that times 0.6, that's 90. Well, man, you're almost at 100% depth of discharge now. And if we've got a battery that's rated at 120, well, that's only 72 ampere hours. And guess what? We're not going to be able to run all that equipment for the time that we need to run it. So if you know your total availability that you've got capacity wise, and you know your total amp draw, this will be a huge plus for you out there when you're actually sizing up your battery bank. And JD, we're going to talk also about some of the ratings because you're looking at AC wattage. So everybody, trying to figure out how do we do that conversion? Well, we've got our little typical load bank here that we're looking at, total number of hours and all that. Well, the way to figure out what you're looking for is you're starting with the AC wattage of the accessory loads, and then we take that and we divide it by 12 because we've got a 12-volt system. Well, everything's got to run through that inverter, so we've got a little bit of a power loss, and it's usually about 1.1. So once we get all that calculated in, we'll take then and figure out exactly how many hours we want to run it. Now, the example we put here together is it's a 1200 watt blow dryer. So we're going to take that 1200 watts and we're going to divide that by 12, and we're going to get, it's 100 ampere hours. Now do that times 0.1 because of the inverter loss, and that's 110 amps per hour that you're going to be pulling. Now, let me just say this. If you've got enough hair that it's going to take you an hour to dry it, man, I want to see what you got.
All right, Jeff. Take us through, what about charging packs of batteries? Take us through kind of series and parallel connection.
Gotcha. So as we're looking at our series connection here on the left-hand side, so the way you can increase voltage is taking two batteries, and you can go 3, 4, 5, whatever you want. But as you go from one battery to the next, so negative of one to positive of the other, you're going to increase the voltage. Now, as you increase voltage, you cannot increase the capacity. So this example here we're actually 12 volts times 2. Well, that's going to be 24 volts with 500 CCA and 120 RC. But when we go into parallel, we actually keep the same voltage, but we increase our capacity by 2, 3, 4, whatever you've got connected in there under a parallel connection. So in this case, we keep 12 volts. We've got 1,000 CCA capacity now and a 240-minute reserve capacity rating. So that makes a big difference when you're looking at capacity that you need to run all your different pieces of equipment. Now, we always love to throw this one in there, and we call this the series parallel connection. Now, you guys, the mechanics that are out there that have been swapping out batteries forever and a day, hopefully you've done like we've done in the past, and you'll either do a drawing for a schematic for all your different connectors before you take these batteries apart, or now that we have these wonderful cell phones with cameras on them, we can actually take pictures of these connections. So that way, when we change out batteries, we can go back in and hook these things up correctly, because some of these systems do not like seeing 24 volts when they're designed to be 12 volts. So we want to make sure we get these things hooked up correctly. So in our picture here on the left-hand side, it's a series parallel connection with 12-volt batteries. So we're actually getting 2 6 volts in each line. And so this is going to make the batteries, it looks like a 2 12-volt battery bank that we're actually got 4 batteries connected together. So this is your series parallel connection. Still got 12 volts, but we went from 225 ampere hours per bank there up to 450 now with that parallel connection. Now on our other side here, we've got a 24-volt connection that we're basically doing the same thing, only we're doing it with 12-volt batteries. So hence you see 24 volts and you've got 1,000 CCA and 240 on the reserve capacity. But the key thing here is make sure that you've got your connectors hooked up in the right polarity. If you don't, your system will let you know about it really quick. And some of these systems, if you take out a converter, that's about $3,000. So, if you guys are doing the installs, make sure you're looking at it correctly.
Thanks,
Now,
Jeff.
you're welcome.
Sorry, I didn't mean to step on you there. So
That's
we
okay.
talked a little bit about understanding ratings and how to communicate those to your customers. What are some of the things that shop owners or service managers need to be asking of their battery supplier?
And this is one thing that Interstate really strives off of for having the freshest battery on the rack when your customers come in to buy. So, even if you're not an Interstate dealer, get with your suppliers and make sure that you know the battery codes and how to read them. So that way you do know that you've got the freshest battery on your rack that you're selling. We've been into stores that we've seen batteries that are 1.5 to 2 years old that are sitting there that have not been sold, that have not been charged, and that can really, really take out a battery, which we'll discuss that in just a few. So when you look at this battery, the picture of the slide here, the sulfation is what really kills the battery itself. And batteries from day one will start sulfating. That's why when we're looking at date codes and our route drivers are looking at date codes, we're going to rotate batteries out to get them charged back up. Because what we're doing is we're taking this white crystals that you see on this plate, we're actually taking that and we're charging the battery back up to actually dissolve this and get it mixed back up with your electrolyte solution in the battery itself. And we typically do anywhere from 3-month to a 6-month rotation. Find out what your battery supplier actually does and make sure that you are getting the best battery that you can to sell your customers, even if it's not the Interstate. Make sure you know what you're selling. Some of these will have little date dot codes on them, like you see here in the upper right-hand corner of that picture. So some of these are just stuck on the battery, and it's basically looking at a rotation of when they took it back and they charged it up. But make sure they're actually doing that. We've got a lot of cases where we've seen where they'll put a date dot sticker on there because the route drivers do not want to take them back and do it. And I'm not talking about Interstate route drivers. I'm talking about any of your suppliers. So we want to make sure that we've got the freshest battery out there for you, and make sure that your battery supplier is doing the same thing.
All right. So up next here, Jeff, if you would walk us through a few of the best practices when it comes to marine and RV batteries.
You bet you. So you've got to set the expectations for your customers. And what we mean by that is you've got to explain that these deep cycle batteries have a break-in period. So when you buy these, they're not fully formed yet. It's just like your automotive batteries that aren't fully formed. But once these automotive batteries get started, once or twice or 4 times, they're building up capacity relatively quick. Your deep cycle product doesn't do that. It takes time because you've got thicker plates, more paste material, and you've got more what we call real estate to be able to get broke in. So these batteries, deep cycles, can take anywhere from 25 to 50 cycles before they're up to full capacity. So we've got to make sure that we are educating our customers out there as we're selling this product too, because, they may be calling you in a few days going, hey, these batteries suck because, we're not getting any runtime out of them. Well, if you get that expectation out there for them in the beginning to let them know, hey, keep in mind, these batteries are new. They're going to take 25 to 50 cycles before they ramp up to capacity. But when they do, man, they're going to take off and they're going to run. So we also know that fully discharging batteries will definitely shorten the life. So 50% depth of discharge is really what we recommend for taking a battery down. And that really prolongs the life of the battery itself. As you look at charging, which we'll talk about here in just a few, it's all about getting the battery charged up with as less heat as possible. Now, your seasonal usage, which, here in Texas, unlike some of you guys up north, here in Texas, we actually have quite a bit of summer, spring, and our fall even stays a little warm. So unlike folks in the north where, they get about 2 months of summer and that's about it. When you start these start storing these batteries, we definitely want to make sure that you start out with them completely charged before you put anything in storage. You know, temperatures as they drop, of course, the self-discharge slows down, but it's still going to have a self-discharge going on. Now, what we would like to have you do is every couple of months, go in and do a full charge back on these batteries, especially if they're not hooked up to any kind of a tender. So every couple of months, come out, fully charge the batteries, and you don't have to worry about them not being ready to go when that summer comes back around again. And on our maintenance, holy smoke, we could go into a long dissertation about maintenance. Now, we want to make sure our connectors are tight and that our vent caps are left on tight. If you're going to add water, we recommend distilled or deionized water. No mineral water, no Gatorade, even though it's electrolytes. We don't put that in our batteries. We don't want to add mud puddle water. And we've even had cases that we've had guys that have told us that they have urinated in the battery because they didn't have any water. Please don't do that. I don't know how good that's going to work for the battery at all, but please don't do that. Distilled or deionized is what we want you to put in there. Now, trickle chargers, you know, everybody says, hey, I got a trickle charger. You know, it's a 950 milliamp. I'm going to hook it up on there and it'll keep it charged all month or all winter. That's not the case. They're not a true charger. So if you've got them hooked on individual batteries versus a series, I mean, there's going to be a definite drawback from there, because if you're only talking a 950 milliamp trickle charger, you're never going to get a battery charge. And they're kind of like maintainers. So if that battery state of charge is at 80%, well, it's going to maintain 80%, or it's going to try anyway with that little bit of amperage that it's pushing. So make sure you've got the right charger for the application that you're going to be running.
All righty here. Quick question that we've had come up, Jeff. What's the best way to charge marine deep cycle batteries?
A charger. I'm just
What's
kidding. I said a charger.
Charger.
No, seriously, you've got different kind of chargers out there. You've got automotive, you've got deep cycle, you've got AGM. You've got to make sure that you've got the right charger for your battery itself. And we always, one of the things that Gale and I have always done in our classes is we talk about safety. So make sure you've got gloves, glasses. You know, we talk about PPE, your personal personal protection equipment. Make sure you've got all these different things, because heaven forbid you have what we call a rapid disassembly happen. So we want to make sure that we've actually got the right charger for the battery itself. So make sure your chemistry is correct. If it's an AGM, make sure you got an AGM charger, or at least an AGM setting for that charger. Check the amperages. Maximum we want to go is about 20 amps for each 100 ampere hour capacity that you've got. Make sure you've got an automatic charger. Automatic chargers are designed, once it gets the battery fully charged, it goes into what we call float mode or maintenance mode. A lot of these newer chargers have actually got a setting now that's within the microprocessor boards that after 28 days, it'll go back in. If it hasn't saw a move in voltage, it'll go into a rebulk, and it'll go in and charge for about an hour before it goes back in to that float or maintenance mode, and it starts that timer all over again. Now, our chart over here on the right, we're going to show you 100%, which is anywhere from 12.84 or 6.842 on a 6-volt. Now, look at your totally discharged battery rating or voltage. At 0% state of charge, we're at 12.01 or 6.00 on a 6-volt battery. There's not a large variation between 12.84 and 12.01. So a lot of folks say, well, I saw my battery, it's at 12 volts. It's a 12-volt battery, so it's 100%. Wrong answer. Keep this chart in mind. When you're charging these batteries, you know, you want to monitor them. So once you get it hooked up, and especially if you're using a 20 amp charger, come back in about 30 minutes and actually lay your hand against the side of the battery. If it's hot to the touch, it's overcharging. If you smell rotten egg smell, and you know it's not you and your buddy's not anywhere near, you'll know it's the battery that's actually gassing. So that rotten egg smell is it's emitting hydrogen, and hydrogen and oxygen make one heck of a capability for an explosion. So any kind of a spark or arc can actually set these things off. So if you smell that, turn the charger off. Do not try to disconnect it, because any kind of arc can set that off. So just turn your charger off. Let it settle down, come back in an hour or so and check the battery then. If it's cooled off a little, then you can actually disconnect the charger itself. We don't need that rapid disassembly happen. And when we're talking about charging, I think we're going to have a little video here of me, which I'm sorry you get to deal with me, but we're talking about the charger here and the two different settings that we've actually got on this, and a 2 amp or a 6 amp. So you know your charger. What you want to do is then hook up your connectors onto the battery itself. Now remember, you're not hooked up or you're not plugged into an outlet yet. So hook the cables up, plug it in, and then come back and turn your charger on. Now you'll see the amp meter swing up here. That actually shows that it's actually putting something into that battery, and it's kind of determining how much do I need to let this thing keep going. So your charger is going to kind of dictate where this thing's going to shut off once it's completely charged. But make sure you've got the right charger for the battery itself. And a lot of folks just don't understand chargers. Now, they say, oh, I've got a 25 amp charger and I've only taken out 50 ampere hours, so my battery ought to be charged in 2 hours because that's 25 amps an hour that I'm putting back in. So that's 25 ampere hours per hour. So in 2 hours, I'll be completely charged. Wrong answer. So when you look at this, chargers are actually designed to be voltage regulated. So what we mean by that is the first stage that goes through here is going to be the bulk. So it's going to put back in the bulk of what was taken out. So if it's 25 amps, it may run 25 amps for an hour. Well, it's put back in a lot of that capacity that was taken out. Well, then it's going to go into absorption. So it goes from constant current amperage going to a certain voltage threshold, and then it hits the roof, as we call it, which is that voltage threshold. Well, amperage can't keep going on. So with that threshold being hit, amperage has no other alternative but to start tapering off. So this is where your longevity comes into play, as far as these things can take, and especially if you're at 100% depth of discharge, you can be anywhere from 10, 12, 14, 24 hours before you get this battery back up to a full state of charge. So keep that in mind when you're thinking about being out on the lake, running these batteries all the way down, or if you're actually running your accessory loads sitting at a campsite. Make sure you understand the chargers and how they're designed to actually put back into the battery, and make sure it's going to be done efficiently without heating it up. Now, our little example down here in a battery. Now, I'm going to kind of give you a weird analogy here, but keep with me here. So we've got 6 individual cells here in this battery, and each cell is going to produce 600 CCA, 180 on the reserve, or 100 ampere hours. Now, inside of a battery, we talked about series connections earlier. Well, inside the battery, there are 6 individual cells that are actually connected in a series connection. Each cell is going to produce 2.14 volts. Each cell is going to produce whatever this capacity rating is within this battery. And as you guys can see, it's 600, 180, and 100. Well, remember, in a series connection, you're only as strong as your weakest link. So in this case, we've got one cell that is actually low. So our capacity reading here is 400, 120, and 70 ampere hours. So that's a big difference there. Now, a way that you can actually look at this, because the charger is going to keep pushing to try to charge it up. So it's trying to fill up this cup of water. And let's just say this cup of water has a hole in the bottom. Well, this charger is just going to keep forcing amperage in there to fill it up, because it senses that there's a void there. So it just keeps filling and filling and filling. And what happens is you'll get the battery that starts heating up and it starts gassing. And we could have that possibility of rapid disassembly, as Gale has already called it. And that is a battery that comes apart really quick. So we want to make sure that you guys are educated on that. Your specific gravity readings, if you have availability to check the specific gravities, and that is basically reading the ratio of sulfuric acid to water. The higher the specific gravity, the higher the state of charge. So if you can look at these individual cells and see what the specific gravity readings are, if one of those cells has got a 50-point variation in it, then all the others, you know, that's a bad cell. That's going to be your total power availability. So in a case like that, the best thing to do is replace that battery.
All righty, Jeff, thank you so much. A lot of great content. Thanks for walking us through that. Wanted to just do a quick recap, and then we'll get into some of the Q&A. So starting out, like we talked about at the outset, the industry, marine and RV, is looking bright and sunny. We've seen momentum just carry right through winter. So expect, as we enter into spring and summer of 2021, it's going to be a great year. Just a reminder that Interstate has a new EFB offering. We talked about that, a Group 24 and a Group 27 enhanced flooded battery. Again, a little bit more money than a traditional lead acid, but you're getting a lot more battery for that money. Knowing your batteries can help you be a trusted advisor and an expert for your customers by understanding and applying ratings correctly, setting expectations. We talked a little bit about that break-in period as an example, and then best practices around charging and maintaining. And again, a reminder, lean on your battery provider, be asking them questions about how they perform rotates. Are they doing everything they can to ensure that you're keeping the best product on the shelf? Because you don't want to go sell an 8-month-old battery to a customer and have that come back to bite you later on and put a bad impression on you and your business. So let's get into some Q&A. Before that, I just want to call out that we do have more content available on interstatebatteries.com/ProClinic. So go there for some additional battery training. And we will have a survey at the end of this sent out. If you would take that survey, we'll be sure to get you a copy of the presentation as well. So with that, let's get into some Q&A here. I'm going to pull up the questions. All right. So the first one reads like this: how do I determine if a battery is enhanced flooded versus a traditional battery? I think, Jeff, from what I've seen, most folks that have an enhanced flooded battery call that out. It's either written out,
Yes.
It'll say it on the label, EFB or enhanced flooded.
Yes, sir, you're
those are
right.
typically the number one indicator.
That is correct.
All right, let's see what else we have here. We had the next question here is: we had a 2016 Jeep with start-stop, and it was an AUW battery. Do you recommend replacing the main battery with the aux battery? I think AUW should have been aux.
Yeah.
Do you recommend replacing the main battery and the aux battery at the same time?
Well, and JD, we've dealt with this quite a bit over the years, and especially since start stop actually took off. No pun intended there. So typically your auxiliary battery, they can last pretty much 3, 4, 5 years before you end up replacing those. So, I mean, yes, if you want to, you can do it. But for the most part, from what we've seen, they don't pull that much on them when they're in the down use, so, but it's totally up to the customer themselves. I mean, we've seen them where they're 4, 5, 6 years old now, and they're still fine. But if you want to increase that sale, go for it. Sorry.
So you can, but it's not necessary.
Exactly.
Got it. Okay. Let me get another one up here in the queue. What is the max voltage you should discharge any battery to avoid damaging the battery?
Well, we really beat them up here in the lab. So we take them down to 10.5 or 5.25 if they're a 6-volt. We've always said 50% depth of discharge is really the best for a deep cycle battery. And the reason behind that is, and the way we can actually monitor that is, if you've got a low voltage disconnect on your unit, if you'll set that at 11.9 as a cutoff to where when it's drawing it down to that point, it'll actually kick off the draw. And so what it does then, with that draw being disconnected, the voltage will start creeping back up. And it should hover in the 12.4 range. And that's your 50% depth of discharge. The reason for 50% depth of discharge, as you're recharging, you're not creating heat, which heat does kill a battery, and it actually will bake the paste material off the grids. So that's why we've always said, 50% is the best way to go.
All right. The next question has to do with maintaining, and it said, are you suggesting you should charge a battery every 2 months? Does that apply for certain types of batteries, or is that across the board, regardless of it being flooded lead acid, AGM, lithium, et cetera?
Exactly. Well, with lithium, you can kind of get away with it because they actually have a BMS, a battery monitoring system on board that'll actually shut the battery off after 15 days. Typically, that's what we see if it's in non-use. So that's good. With the flooded or AGM product, now keep in mind, AGM product is it's an absorbed glass mat, so the self-discharge is a lot slower than what you would have on a typical flooded. But now anything that if it's hooked into a system like on a vehicle that's got a constant key off drain, those you definitely want to monitor a little bit more specifically because, if you let those set for 2 months, you're probably not going to get it to start. So in a case like that, you probably want to try to find a trickle charger or maintainer or something to keep on it all the time. But on your seasonal batteries like that, every 2 months is really a good rule of thumb, whether it be on flooded or on AGM, because either way, you don't want them to sit there long enough to where they're actually going to start sulfating. So 2 months is just kind of a rule of thumb for any of them except for lithium.
Great, thank you. All right, next question reads like this. It's talking about bringing batteries back to life. Can you repair an AGM battery that will not take a charge by using 2 chargers to force the amperage and dissolve the phosphate? Or what is
Well,
the best way to fix an AGM that won't hold a charge?
well, let me just tell you this. 2 chargers are not going to work because what's going to happen is they're going to be fighting each other. So whichever's got the higher capacity is the one that's actually going to work, and the other one's going to it'll either get backfed or it just won't work at all. The best way to bring an AGM product back is to trick the charger. And the way you can do that is you can take a known good battery, and if it could be a flooded or AGM, it doesn't matter, and you hook them in parallel together, positive, positive, negative to negative, and then you'll hook that charger up to the good battery. So now this charger sees one big battery there, and you've got a circuit that's connected with the 2 batteries going positive, positive, negative, negative. So now you're tricking the charger to force current into both batteries that'll actually finally get that other battery, the AGM, that's kind of at a lower state of charge. You can actually, and we always said, 30 to 45 minutes, go back and check. And you might be able to go ahead and disconnect that good battery and just hook the charger up to that other battery that was low, and it should continue to charge, because the chargers have to see X amount of voltage before they'll actually start charging. A battery that's sitting at 4 or 5 volts, a charger is going to say, no, this is not a good battery. I'm not going to waste my time. But if you know that it was drawn down for a particular reason, then that's the way you just, once again, trick the charger.
All right, thank you. So this question here says, when a customer calls in requesting a battery for their RV house or their chassis, what are some leading questions I can ask to help determine the best battery to offer them?
Well, and one of the things that we've always looked at is, how often do you dry camp or boondock? If these customers are relentless about using batteries and they don't want to be hooked up to shore power, well, then that's where you get with them and see what kind of space they have available. And if they've got space for the 903S or 903HCS, which are the L16 batteries, that's great. If they've only got room for like the GC2 batteries, then that's another option as well. And you can do some series parallel connections to get the capacity. But the key thing you do want to focus in on is, how often do you use your batteries? I mean, if they're continually hooked up on shore power and very rarely use batteries, well, then you can kind of gauge it out from there if you want to go with the 210 ampere hour 6 volts, or whether they want to go with just some 12 volt flooded or AGM product. You kind of weigh it out with them, because heaven forbid you don't ask the right question about what's your your capacity drawdown, how often are you doing it. I mean, because that can actually come back and haunt you. And we've had many customer service calls about that as well. So just kind of gauge it with your customer. You need to know how they use them. That's the big key.
Great, thanks, Jeff.
Mm-hmm.
Are EFB batteries a suitable choice for backup sump pump systems?
I got a feeling I know who sent that in. I'm not going to call out any other names, Jeff. But anyway, sump pumps, yeah, very good application. Even dump trailers, another good application there. The key thing to focus in on is, once again, the charging aspect. And we get this a lot, and I know some of the folks online that are listening to me have heard me say this over and over again, and they'd probably love to reach through the phone and just slap me. But I want to know what kind of charger they're actually using, and how often is it going to be charged, because these batteries, if you take them down to 100% every time you use it and you wait a week before you charge it back up, that battery's not going to last. They're not designed to be that way. If you discharge a battery, you want to charge it back up. So these applications, yes, they can be used in a lot of different applications, but the key factor is, you got to know how they're going to charge them. How often are they going to charge them? How far down are they going to draw them on depth of discharge as well?
Great, thank you. This next one here, I believe you've hit on, but maybe just a quick short answer. can use the same charger on a flooded battery as an EFB.
As an EFB, they are typically the same charging algorithms. There's only like 1 or 2/10 of a volt difference, which doesn't make any big difference at all. We've actually noticed that the EFB product actually charges a little bit quicker than the typical flooded product. So it'll actually probably come up to a quicker state of charge quicker than what that other typical flooded marine product is.
All right. Are marine batteries a good choice to suggest for people who want to use them in solar systems?
You know, I'm gonna have to raise the flag and say probably not. And the reason I say that, when you're looking at solar applications, you're looking at, and especially if you're running like a little small shop, or even if you're running your house, these batteries are small to size. And so when you look at the overall capacity, there's not a whole lot of capacity in there. So I'm going to have to say no, I would not recommend that for a solar application, unless this is just like putting data collection equipment out somewhere. And in a case like that, I would say you would probably want to use an AGM product, because if it's collecting data somewhere, they're probably not going to go out every day to look at it. So once again, you're just going to have to weigh out what the usage is going to be. But in a typical solar application for like a small shop or a house, no, I wouldn't go that direction.
All right. If you, Jeff, were going to engage with a customer, how would you describe the break-in period for, lead acid deep cycle batteries to an RV customer that might have questions about it?
Oh yeah, that's an easy one. So when I'm talking with customers, and Gale and I've done this over the many years that we've been doing this at some of the FMCA shows, Family Motor Coach Associations. So we've dealt with this quite a bit, and we've got to let them understand that, batteries, as they're brand new, you got to break them in. It's kind of like you're breaking in your new car. You don't go wide open every time you get in it. Batteries are kind of the same way. You want to get them broke in. So discharging, and it doesn't have to be deeply discharged, shallow discharges, anything that's going to basically wake that battery up. We want to educate them on that. And, 25 to 50 cycles is not uncommon to bring batteries up to a full capacity. But once they get to that full capacity, these things are going to run, and they're going to run, and they're going to run. And they will stay running as long as you take care of them and keep the maintenance up on them. So just educate them 25 to 50 cycles, and they'll notice it's almost like an overnight difference. And we've noticed that in the lab as we do the ramp ups on them, 20 to 30 cycles, and we see this thing just increase by, 15, 20 minutes. And you're like, wow, I think we shook it up enough. So just getting them broke in.
Great. All right. This next one here is a little longer. When my customers have a traditional motorhome with a regular alternator, then go from a wet cell to an AGM or lithium ion batteries, is there an adapter to allow the alternator to charge a wet cell chassis, an AGM, or a lithium ion RV battery at the same time?
Well, I'm assuming they're going to have an oscillator in there. And, you kind of got to look at the system itself, because the oscillator is going to, send back what it can from the alternator. The alternator is going to be voltage regulated, so it's not going to be like it's 15 or 18 volts. So AGM, yeah, I mean, and especially you don't have an AGM as far as a cranking battery. So if you got two mixed chemistries, you got to remember Ohm's law comes into play, and Ohm's law states that current follows the path of least resistance. So remember, we talked about AGM product being a lot lower internal resistance. Well, guess what? It's going to get quite a bit of it. Your flooded product's going to starve. So with an oscillator, you kind of weigh that out a little bit, because it will continue to push back to that AGM product, and will eventually get it charged back up if it's been deeply discharged. Lithium, on the other hand, it's a totally different chemistry here now. Now, the nice thing about lithium is the way they're designed with these BMSs on board, the battery management systems, it will not allow that battery to take more than it's designed to take in, and it'll shut the battery off. So that's a huge plus on that side of it. AGMs don't have that luxury. They're going to keep taking whatever you keep throwing at it. Flooded product will be the same way. But once again, the key thing is it's voltage regulated at the alternator. So
okay.
That's what keeps everything a little bit safer.
Great. I know we are a couple minutes past time here, so let's do one more question. I know there's quite a few that we didn't get to. We will circle back with you guys if we didn't answer your question already. So last question here. I've seen 2 or 3 of these now, Jeff. and that is around venting on EFB. Is it different, and how is, if so, how is it different from a flooded lead acid?
Well, so in a lot of your flooded product, you've got the raised bit caps, as we call them, the best in class caps, and they're designed to basically, as your batteries are charging and they're gassing, and every battery's going to gas. That's normal. So what happens is, as the water molecules are actually coming up, that cap itself, the lid, will drop that water back down inside. So that way you're very low on water loss. So those are a little bit different design than what your single port vents are, which actually will come out to the front on one of the sides, and that's the single port. But it's got all 6 that actually come into one that migrate in, and then it's just got one exit zone. Well, when you look at the EFB product, it's a port that runs all the way across the top, and you'll see the little individual caps that are on there, which are basically, they're little bitty small round circles is what they look like. And they've got a baffle set up in there that it's almost like your AGM product, where it'll actually kind of just expose a little bit of the air to come out, and it'll vent through either end of the battery. It doesn't matter which, if you want to use a vent system on it. A lot of people will use vent kits. That's fine. Just block off the one end that you're not using. But they're designed to basically burp the battery as it's charging. That's what every venting system is designed to do. If they did not have that luxury, guess what? That battery would swell up to the point where it's going to come apart.
All right. Thank you, Jeff. I appreciate you taking the time to walk through this content and answer these questions. I want to thank all of our participants for joining today and asking these great questions. This helps us shape future content as we build out future webinars. So I appreciate the involvement. We didn't get to all the questions. So again, we will circle back with those folks that we did not respond to yet. Just a quick reminder, there is a survey. Please give us your feedback. What went well, what didn't. That's going to help us, really kind of mold future content. So your feedback is valued. And we will also, if you submit that survey, we'll give you guys a copy of this presentation so that you can go back and review content at your leisure. Thanks again. Hope you all have a wonderful day. Take care.
Thanks, everyone. Appreciate it.